All right, so my last video got cut off like literally seconds before I would have ended it anyways, so it almost feels like it's not worth making a part 2 here. But I did want to, adequately address this picture right here. So again, what I was talking about was the fact that these tangent line, these approximations for tangent lines, because there is error here, it's sort of a compounding error. We're going to see in most cases that this gap just continues to grow, the gap between these points that we're using to approximate actual points on our solution curve. Now you'll see here this thing called RK4 method. That's Runge cut of order 4, which is another numerical method that's used and practiced a lot. Euler's method, even though we're talking about it here, it's actually one of the worst numerical methods out there. It really does not do a good job at approximating solutions in most cases, and so it's almost never used in practice. But the reason we talk about it is because we can take Euler's method as sort of a foundation and improve on it come up with other better methods that are based on this. Okay, so we'll talk about that at the end of this course in Chapter 9. We go over some more of those methods. Runge cut of 4, RK4, is used a lot in practice, and you can see the red lines here are corresponding to that method. You can see how tightly they hug that solution curve. Just from the image, you can see it looks a lot better than Euler's method. But again, that's a Chapter 9 topic. We'll wait until then before we really kind of dive into that. And this teeny tiny little video is going to wrap up Chapter 2 for us.